All right, I want to look at problem 55 on this. So the Ravens scored 13 more than 3 times the number of points that the Bengals scored in their last game. If the Ravens scored 40 points, how many points did the Bengals score? So we have to write an equation. We're trying to find how many points the Bengals scored. So that's like my variable. So if I'm writing the equation, the Ravens scored 13. What does more than mean? Greater than, so we would add. Does everyone know that? So 13 plus 3 times the number of points the Bengals scored. And the number the Bengals scored, that was my x. So 13 plus 3x is the Ravens score. And how many points did the Ravens score? 40. So we had to write an equation. You have to know what your variable is in order to be able to write that equation. So a lot of times on the EOC, they like to give you a scenario like that. And they'll make it a 2-part question. Part 1, they'll say write the equation. So you have to be able to type this in. Then part 2, they're going to say solve it. So if we're going to solve this, we would subtract over the 13. Divide by 3. And we get 9 points. So the Bengals scored 9 points. I want to go down to 59. So this one is giving us an equation. The total cost to rent a pontoon boat for 8 hours can be represented by this expression. If Brianna can spend a maximum of $200, how many hours can she rent the boat? So what I know, this is her cost, and she can spend $200. So we'll set it equal to 200. So now if I want to solve that, we subtract the 65. Divide by 30. And what's 135 divided by 30? So she can rent the boat for 4.5 hours. All right, that is the end of what we are covering in packet 1. I want you guys to circle 56 and 58. Those are the last 2 questions you have to do out of this packet. So, just like the previous one, I'm going to skip around a little bit on this. So, when we are talking about functions and relations, and when we went through these, you might hear these terms, so they're probably not going to ask you definitions on the EOC, but they'll use the word, so you need to know what they mean. A relation is just a set of ordered pairs. The domain is your x, and the range is your y. A function is a special type of relation where there are no repeating x values. So if we are checking if something is a function, we can look to see if x repeats. Remember when we were talking about the graph, we checked to see if it passed the vertical line test. If you could draw a vertical line that ever hit it more than once, that meant x repeated, so it wasn't a function. If anywhere you drew it, it only touched the graph once, that would be a function. So relations can be represented lots of different ways. I might just give you the ordered pairs, I might give you a table of values, I might give you a graph, any of those things. Did you have a question, Katie? Happy to help you if I can. So number one, if I'm asking you for the domain of this, I'm asking you just to tell me what the x values are. A lot of times they'll be written in a solution set. That's just the squiggly brackets, but domain, you're just listing the x's. So the x row is -1, 2, 5. We have -1 again. You don't have to write it multiple times. You just write it one time. The range is your y's. What are my range values? 7, 3, 0, 2. Order doesn't matter, so you can put them in any order. Then we have to decide if it's a function. A function means x doesn't repeat. When I look at this, I have the same x value twice. So that means it is not a function because my x repeated. Remember, any problem I'm writing down, you need to have written down. So make sure you are doing this with me. Crazy. All right, let's talk about number 4. This one is a graph. The domain. We have to think about our x. When we did these, I said, okay, think about it going from left to right. So my first x value, if I'm starting on the left, starts here. That's at -3. We're going to write an inequality. So -3 is less than x is less than, if we keep going, I hit all those x values until I get to +3. But that one's an open circle. How did we show that on the inequalities if it was an open circle? If it's a closed circle, it gets the line underneath. Remember, if it's open, it's just the less than symbol, no line underneath. Okay, so these are things that we've talked about before, but if you don't remember something, make sure you're asking some questions. Our range is our y. So I told you, think about going from the bottom up. So if I'm coming from the bottom, here's my first point. That's at -4. Range, the variable is always y. This one, it keeps going up. I keep hitting points until I get right here, which is at 5. There were no open circles, so it's everything between -4 and 5. To decide if it's a function, I am seeing if it passes the vertical line test. That means if I draw a vertical line, it can only hit my graph once. And when I look, no matter where I draw that vertical line, it only touches my graph once, so it is a function. So if I look at number 6, my domain, as I'm coming from left to right, my first x value is right here. That's at -2. So that's less than x, and it keeps going. So you might just see it written like that. There's no stopping point, or you could just write x is greater than or equal to -2. It hits everything bigger than -2. There's no stopping point, so we don't have it in between two numbers. The range, this end is going to keep going down forever, and that one keeps going up forever. So if we go far enough out, it's hitting all of those values. So if it hits everything, we just say all real numbers. To decide if it's a function, we have to look, do any vertical lines hit it more than once? So if I'm drawing vertical lines, can we draw lines that hit it more than once? Yeah, quite a few of them. See, these are all hitting it twice. If that happens, it is not a function. What questions do you guys have there? Does everybody have all of those down? Let's talk about function notation a little bit. So when you see this, let's look at number 7. This is just asking you to do an operation. It's telling us that f of x is -x minus 7. So when I say find f of -5, all it's saying is you go to this expression and you replace the x with the negative 5. That's the number I'm plugging in for x. So if I do that, two negatives make a positive, so 5 minus 7 is negative 2. You can also use your calculator on those at any time. So you just have to know on those, when I give you that function notation, you are replacing your x with this. Alright. Let's jump to problem 13. It's still asking for that function notation, but it's giving it to us in a different way. So on the graph, instead of giving us the equation, it gave us a picture. And it wants f of 3. Okay, think about your notation. The number in parentheses is the x, so 3 is the x. So what this means is if x is 3, what is your y equal to? That's what we're trying to find. So I go to my graph when my x is 3. So if I go over 3, finding out where that point is on the graph. So when my x is 3, the y value is 1, 2, 3, 5, 6. So the number in the parentheses is your x, you're finding your y. You can do that if you have the equation or if you have a picture of your graph. Do you guys understand how I got that? Let's talk about zeros. We did it with our parabolas recently, so we can do it from any graph. Remember, a 0 is just where it hits the x-axis. So it's just like when the equation is equal to 0, what's x? If y is 0, what's x? So if I'm looking at a picture, when I want the zeros, I'm just saying, okay, where does it hit the x-axis? What's my x value right there? 2. Okay, 17. Where it hits the x-axis, what are my values? Mm-hmm. All right, if I look at 20, that one gave me the equation. You have two options. You can factor it, or we talked about, you get Desmos on this. Why don't you guys pull up Desmos and type this equation in? Tell me if you can give me the zeros from that. So from Desmos, it's pretty easy. If you didn't use Desmos, you would have to factor it. We're figuring out when it's equal to 0. So remember, we've done a lot of these at this point. So if you chose this route, you're looking for what two numbers? Multiply to negative 40, add to positive 3. And that would be positive 8, negative 5. And then we set those equal to 0. So whether you worked it out or used Desmos, you get the same thing. And both options are available to you for that test. All right. Any questions there? Now let's review lines a little bit. So I'm actually going to go to problem 24. Do you remember doing slope? It was one of the very first things we did this year. How do we find slope? Yep, slope-intercept form. We wrote those equations. So if you have the equation written, you can look at it. If you're looking at a line, remember rise over run. So all of that stuff is what we looked at there. So if I'm doing rise over run, just looking at if I'm at one point, how much do I have to go up and over to get to the next one? So I go up 1, 2, 3, 4, over 1, 2, 3, 4, 5. It does need to be in lowest terms, so if you got like 8 over 10, you have to reduce it. You can always use your calculator to help for that, but to find our slope, we just counted. Rise over run. Remember, if we had ordered pairs, there was a formula. Change in y over change in x, y2 minus y1 over x2 minus x1. On the EOC, there is a formula sheet, and that is on there. So we just have to be able to use it. You could also, if you really got confused, use Desmos. You could plot both of those points on Desmos, get the graph, and count rise over run from there. But if I'm looking at the points, this is the x of the first, the y of the first, x of the second, and y of the second. So when we do our equation, y2 is negative 4 minus y1 is negative 1. X2 is negative 3 minus negative 12. So minus negative is plus, so we get negative 3 over 9. On lowest terms, it's negative 1/3. Slope is typically left in fraction form because when you're graphing a line, it's much easier to graph that fraction than it is to graph a decimal. So the last few things we're doing are just talking about lines. I want to jump to problem 32. Remember when we wrote equations? Slope-intercept, y equals mx plus b. Standard form, we didn't see it as much. Sometimes things were written like that, ax plus by equals c. Anytime we had something in standard form, we just rewrote it so it wasn't. In this, m is your slope and b is your y-intercept. So on 32, if I'm asking you to write your equation, y equals, your slope is negative 1, that's your m, y-intercept is 4, that's your b. So it's just y equals negative 1x plus 4. You just replace m and b. The actual equation itself keeps the x and the y. If it was written in standard form, we always had to rewrite it. So if I look at 35, if I wanted to find my slope and y-intercept, I have to get it in y equals mx plus b form. So what we did is we would subtract over the 4x. So we would get 10y equals negative 4x minus 10. We divided everything by 10. So negative 4 over 10 reduces to negative 2/5 x minus 10 over 10 is 1. That's my equation. If it's written that way, what's my slope? What's my y-intercept? Negative 1. Good. So one other thing we talked about with lines is x and y intercepts. That's when we just made the opposite variable 0. So to find x-intercept, you make your y equal 0 and solve for x. Y-intercept is when x is 0 and we solve for y. So I'm doing a couple more. Stick with me just a little bit longer. So if I ask for x and y intercepts, another option you have is you have Desmos. You can graph the line and it will give you x and y intercepts. X-intercept is just where it touches the x-axis. Y-intercept is where it touches the y-axis. So you could absolutely just plug this in on Desmos and find those points. If you want to do it by hand, you have to put in 0 for the opposite variables. So to find your x-intercept, that means your y is 0. So you have to add over your x. Either divide by 3/2 or multiply by the reciprocal 2/3. And you get your x to be 6. And you can get it that way. If you graphed it on Desmos, it also gives it to you very easily. So let's kind of look at that so we make sure everyone understands. So if I just graphed y equals negative 3/2 x plus 9. Okay, if I want the x-intercept, it's where it hits the x-axis, and it tells me that point is 6, 0, which is what we just got. My y-intercept is where it hits the y-axis, so what's that point? Yep, 9. So you can see them, sometimes it'll just be the number, sometimes they'll be written as an ordered pair. Desmos is a great option. So when in doubt, you can always use that. So x-intercept, you could say 6, or the point was 6, 0. I didn't work out the y-intercept, but we just found it on Desmos. That was 0, 9. All right. Let's make sure we remember how to graph lines, and that'll be the last thing that we do for today. If I go to 42, if I want you to graph this line, what would you do? Where do you start? Here's your number. Yep, so we start at 7 on the y-axis. My slope is negative 3, or you could think of that as negative 3 over 1. So that means down 3 and right 1. And once you have 2 points, you can draw the line, or if you're like me and you can't draw straight lines, you can make more points. What other option could you use if you forgot how to graph them? Desmos. Type 46 into Desmos. See if you can get that line. So if I type in negative 10x plus 8y equals negative 8, it gives me that graph. You just need enough points that you can plot it on yours, so find a couple nice points, so like 0, negative 1 is a point. You might kind of have to try a couple. 0.8, 0, that's not beautiful, but we can get a point, or it looks like about 2, 1.5, or 4, 4 is a point. So you just have to get enough nice points that you could graph it from there. So that is certainly an option as well. When in doubt, Desmos will work. You just need a couple points, so 0, negative 1, 4, 4, and then we have our line. Right, 48, x equals negative 5. What's that look like? Type it into Desmos if you don't know. What's x equals negative 5? Left 5, it's just a vertical line going up and down. So the nice thing is Desmos will help you on all of those. All right, that is the end of the problems I am doing with you. I need everybody to get ready to circle problems. So I gave you 2 problems on the first packet. On this packet, I'm not going to give you a ton. packet 1, you should have already circled 56 and 58. Those are the last two you have to finish from it. Packet 2, you're welcome to use Desmos on anything it will help with.